So this video is for my course project in Data Communication and Networking 1. And this activity or this course project will assess my knowledge and skills in applying LAN technologies and network service required by converged application in a small scale or local network. So this is the part 1 of the course project. So create a video presentation from the topic listed below. Select one group of topics only, and then the video must include an introduction, discussion of the topic, and sample configuration using Cisco Packet Tracer for each topic. And also, the video should include yourself or myself presenting the topics. For the visual content, the student may use different materials and styles, for example, PowerPoint, live discussion, simple discussion, or simple discussion or paper discussion, sorry. And then make sure that your face is clearly seen on the video as well as on the display on the screen. So these are the list of topics here. We have the group 1, group 2, and group 3. So I choose the group 1, which is about the networking fundamentals, network topologies, and network models. So I made a simple slideshow here. And before we start, I want to introduce myself. I'm Karanjoy Fujibayashi. I live here in Japan for more than 4 years. I am taking a Bachelor of Science in Information Technology at AMAOED University. And again, this video is for my course project in Data Communication and Networking 1. So what is a computer network? So a computer network is a set of computers connected together for the purpose of sharing resources. Also, it is a collection of computing devices that are connected in various ways in order to communicate using electronic means. So that's a computer network. So we have components of networks. So we have the end devices and the intermediary devices. What is an end device or end devices? So these are hardware devices. These are computing devices with unique IP addresses that interconnects. So if we go here in our Cisco Packet Tracer, if we click on the end devices, which is really convenient to use, this Cisco Packet Tracer is really convenient to use because whenever you hover something here, you can see what kind or what's the name of that device. So for example, here end devices. So if we click on end devices, we can see PC, laptop, server, and so on. So these here are all example of end devices. Next is the intermediary devices. So these devices provide connectivity to the network, connect individual network, and connect segments with the same network. So again, if we go to Cisco Packet Tracer and then we click on network devices, this here, the switches again, if we hover or you hover something, you can see, for example, this routers, switches, hubs. These are all examples of intermediary devices. Okay, so and then we have the commonly networked devices as well. So one of these is a hub, which is a device that connects multiple computers together and makes them perform the function as a single unit. So again, here in Cisco Packet Tracer, if we click on hub, we can see different kind of hubs here. Next is the switches. So it is a computer networking device that connects devices together on a computer network. So we can see here again switches here. These are different examples of switches. We have the 2960 PT switch and so on. Next is the router. So it is a small electronic device that join multiple computer network together via either wired or wireless connection. This is an image of a router, but if we go to the Cisco Packet Tracer, routers here looks looks different. But we can see that we have different routers here. We have the 4331 and so on. Next is the network card or the network interface card or the NIC, which are hardware devices that connect a computer with a network. So this is an image or an example of a network interface card. Next is the modem. This one is really famous here in Japan, or like most of the people are using this one in their houses or in their homes, because I think most of houses here has their own telephone. So this modem, I think this is a device or a program that enables a computer to transmit data over, or for example a telephone, that's what I said, we have this, or a cable lines. Yeah, so we also have applications that uses a network. So we have some applications that uses a network, like for example games, databases, and email, video conferencing, and the FTP or the file transfer protocol. So we also have my apologies for movie recording. What is this? For my camera. It's too big. Okay, so there are three basic types of network. So we have the LAN, WAN, and the MAN. So LAN, or the local area network, is an individual network that usually spans a single geographical area, providing services and application to people within a common organization area only. So, like for example, in at your home, office, and in a single or small building as well. Yeah, in a one building. So the next one is the WAN, or the wide area network. It is a network connection between two or more LAN over a potentially large geographic area. So what I have learned in from this subject is that before, when I heard about the word wide area network or the WAN, I thought like what comes to my mind is like it's faster than LAN, because LAN is local, so local then wide. So I thought before WAN is faster compared to the LAN, which is local area, but I was wrong. So I've learned that local area network or LAN is faster than WAN, or wide area network. Then the last one is metropolitan area network, or the MAN, which interconnects a number of LANs using a high capacity backbone technology such as fiber optical links, and provides uplink services to WANs and the internet. Yep. So let's go with the network design or topology. So this is my favorite part of the topic, or my favorite lesson. This is the arrangement of computers in a network. So we have five topologies, namely the ring topology, star topology, bus topology, mesh topology, and the hybrid topology. So let's go with the first one, which is the bus topology. So this is an image or an example of a bus topology which is blurred, but I can show you how to do this again. So bus topology is a network topology in which every computer and network device is connected to a single cable. So as we see here. So let's go to Cisco Packet Tracer and create or make a bus topology again, since that one is blurred. And you can use PC here. So this is an example of a bus topology, and as you see here, it's still amber. It means like if it's still amber, it means like the connection is still connecting. While if we see two green triangle, like for this example, so the connection is working fine, as you see here as well. Yeah, so let's just wait, or later on it will change to green triangles. So let's go with the second one, which is the ring topology. So a ring topology is a topology that forms a ring as each device is connected to another device, with the last one connected to the first one. So this is an image or an example of a ring topology. So let's create another one. Okay, so why it's red? Oh, I see. You can see it looks like a ring here, like that. It's really hard to do it without a mouse. Yeah, so this is an example of a ring topology. So let's go with the next one, which is the star topology. This topology is that all the computers are connected to a single hub or switch through a cable. So let's make a star here. And this time we can use the hub. Yeah, so this is an example of a hub of a star topology. Next is the hybrid. Oh, before we go to the hybrid topology, let's go first to the mesh topology. So a mesh topology is a network setup where each computer and network device is interconnected with one another. So this is an example or an image of a mesh topology. So if we go back to Cisco Packet Tracer, this one we can make it a mesh topology by just adding cables here connected with each other. So now we can call it a mesh topology. And the last one is the hybrid topology. So this one is a little complicated for me because it uses two or more different network topologies. Like for example, in this image, we have the star topology, we have the mesh topology, and the ring topology as well. So yeah, that's it. So let's go with the protocols. So protocols are rules that govern communications. In network protocols, describe process such as the format or structure of a message, the process by which networking devices share information about pathways with other networks. So we also have some of the commonly used protocols. We have the HTTP, which is the common one, which is the hypertext transfer protocol, the TCP or the transmission control protocol, the IP or the internet protocol, and the multiple protocol. And a network model or a set of layers and how they interact. There are two most important well-known network models. So we have the OSI and the TCP or the IP model. So OSI stands for Open System Interconnect, and the TCP stands for Transmission Control Protocol, and the IP stands for Internet Protocol. So what is an OSI model? So it is a system that breaks down a network function. It is also the most popular part of Internetwork reference model, and it also consists of 7 layers. So these layers of the OSI models are the following. So we have the application layer, which is the layer 7, the layer 6, which is the presentation layer, session layer, which is the layer 5, the transport layer, which is the layer 4, layer 3, which is the network layer, data link layer, which is the layer 2, and the layer 1, which is the physical layer. And also we have the TCP or the IP model. So it is also known as the DoD or Department of Defense model. And this protocol that is used in the internet, and this protocol as well, this TCP or IP model have 4 layers. So we have the application layers. We have the application, which is the layer 4, transport as the layer 3, layer 2 as the internet, and the network access as the layer 1. So that is all about the part 1. So now let's go with the part 2. Okay, so the part 2 is complete the table. So this should be included in the video. Discuss, explain how you got the answer for each item. So I need to convert the network address to binary, then convert the prefix length to subnet mask or vice versa, and then identify the 3 types of addresses: network, broadcast, and gateway address, and so on. Okay, so this is the table given. So I need to find the answer for this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the first question is, not the first question, the first one that I should answer is this here. I need to find the prefix length of this. So in order to get the prefix length, I need the subnet mask here, and I need the subnet mask to change. I need to change the subnet mask into a binary number. So let's see here, for example. So my answer for the first one is 27. Why? Because here the subnet mask is this one, and then I change it into binary number. So if after changing it to a binary number, you just need to count once. For example, this one, so it should be 8 times 4, 24. So 24, 25, 26, 27. So you just need disregard the remaining zeros. So it will be 27. So yeah, that's it. And I will show you later how to change the number or the decimal number into a binary number. So let's go with the number 2. Number 2 here is I need to get the broadcast address of this. So in order to get the broadcast address, my solution for this is I need first to get the network address and then the subnet mask. So this is my solution for number 2. So I have here the network address, which is here, and then the subnet mask, which is here already. So in order to solve this one, I need to in order to get the broadcast address, we have 3 rules. So the first rule is that whenever you see a 255, it means like whenever you see a subnet mask of 255, it means like you just need to just to copy the network address of each number. So like for example, this one, octet 1, so we have 255, so I just copy the 172. Rule number 2 is that whenever I see 0, it means like whenever the subnet mask is 0, so for example, if I see 0 here, automatically this will be 255 here, like that. Okay, so that's the second rule. And the third rule is if it's not 0 or 255, neither 255 or 0. So I need to do this solution later. So okay, so now it's 255. Octet 1 is this 172, sorry, this 172 and 255. So it's 255, so copy the network address. Octet 2, this is 201 because 255 here, so just copy. And this one as well, so 95, just copy the network address. And enable to get the last octet or the octet 4, the formula is 256 minus this funny number here, which is not 0 and which is not 255. So why is it? So this one is 256 minus 224 will be 32. So what number that is greater than 32, which is near to 32, but you cannot add any numbers, you just need to add by itself. So 32 plus 32, so I think 32 multiply 2 is 64. So this is the nearest number when it because this one is called actually the funny multiplier by some YouTuber, and you can multiply it by 1, 2, 3, 4, 5 and so on, as long as it is near to the 32, bigger but near to 32. So 64, then after multiplying, so we just need to minus it to 1 or subtract by 1, so the answer will be 63. So my answer for number 2 is the broadcast address is 172.201.95.63. Then let's go with number 3. So number 3 here, I need to get the subnet mask. So I have no solution for that because if you just see here, so but my answer is it ends with 128. Yeah. Yep. Because what I did is I just compare it to the first example here. They are totally the same because they have the broadcast address which ends with 255, and also so what I did is just copy this 255.255.255.255.0 because it's understandable that if it's 255 here, it means it is 0. And yeah, so sorry, so if it's 255 here and here, we just all we need to do is just copy the network address here, the last number here. So my answer for this number 3 is 255.255.255.128, which is here. I copy here. Same what if you base on the first example. So number 4 is find the gateway address of this. Okay, so in order to get if we base again to the table, every gateway address is like adding 1 to the network address. Like for this, for example, for this one, 192.168.10.0, but the last digit will be 1. And also this one, that 32, so that 33. This one as well, that 0, that 1. That 64, that 65. So the first 3 octet are totally the same. We just need to add 1 on the 4th octet. So my answer for number 4 is 10 or 10.10.78.129. Next is number 5. I need to get the binary of the IP address. So in order to get the binary of the IP address, I need the network address. So I have the solution for that. So this is my solution for number 5. I have here the network address, which is 192.84.235.0. So in order to get the binary address, as I said earlier here, I want to show you later so that I will not keep repeating myself. So this is the 2 power of 0, 2 power of 1, 2 to the power of 2. So 2 times 2 equals 4. 2 to the power of 3, because 2 times 2 times 2 times 2 is 8. 2 times 2 times 2, yeah, is 8. 2 to the power of 4, 2 to the power of 5, and so on. 5, 6, 7, okay? So in order to change it into a binary number, we just need to segregate or separate each number. For example, 192, 84, 235, and 0, which are here. But there are different ways of getting the binary number. But in my case, I found it more convenient for me to use this one. So yeah, so at first 192. So 192, what is the nearest number that is lower than 192 so that we can subtract it? So 128. So 192 minus 128 will be 64. So since I use this 128, I just need to put 1 here. So that's why I put 1 here, because I use 128. And then the difference is 64. So 64, what is the nearest or the equal to 64 but less, what is the number that is equal to 64 but less than equal to 64? So I think it's 64 again. So I use 64, so that's why I put 1 again, and then the answer is 0. So of course we have nothing to subtract, so 0, 0, 0, 0, 0. Same as the 84 here. So can we divide 128 to 84? Of course not, because the answer will be negative. So it's not necessary to, or it's not good, okay? So the next one is 84 is if we subtract it, it's 64 is less than 84, so we can subtract it, so we can use 1. So we have 84 minus 64 equals 20, and then so we use 64, and then the 20, so 20 we can use 16. 20 minus 16 equals 4, then 4. So we have 1 4, 1 16, and 1 64. And the same process with this one as well, and the 0. And also, if you want to check your answer with this one, you can check your answer by just picking up those one. For example, this 84 here. If we look on the 84 here, we use 164, 16, and 4. So if you add this number, so 164, so 64 plus, at first, 4 plus 16 is equals 20, right? Plus 64, because we use 1, will be 84. So yeah, so if you want to check your answer, if that number will match, so it means like your answer is correct. So my answer for number 5 is this one. Lot of 0, yeah, 1 1 0 0 0 0, and so on. So many 0. So the next one, number 6, is finding the broadcast address. So it's like number 2 here, but number 6 I think is easier, because we can apply the first rule, which is 255 here, and the second rule, which is day 0. So again, the first rule is whenever we see a 255 from subnet mask, we just need to copy the network address. And whenever we see a 0 in rule number 2, we can just write or disregard whatever number it is, just write 255 in that octet. Okay, so octet 1 2 3 4, octet 1 2 3 4. So compare 255, so just copy 84 255, so just copy. 255 235, so just copy. And then 0, remember rule number 2, just write 255 whenever it is 0. So my answer for number 6 is the broadcast address is 192.84.235.255. Next is number 7. So again, it's the same process. So my same process or same sorry, so I will show you the number 7 here. Again, we need to find the prefix length of this, but in order to get again the prefix length, I need the subnet mask and turn it into a binary number, then count the ones only and disregard the last remaining 0. So my answer for that is 26. So this is my solution because 8, this is 8, 8, 8. So 8 times 3, 24, 25, 26. So my answer is 26. Okay, so number 8. Number 8 here is, finding the broadcast address. So again, the same process as usual. In order to get the broadcast address, I just need to get the network address and the subnet mask, and then compare each octet with each other, then apply the rule number 1, 2, or 3. So my answer for number 8 is the broadcast address will be 172.99.184.127. And number 9 is getting the binary of the IP address. So again, same process. Getting the binary address, you just need to get the IP address, which is here, and then turn it into a binary number. So simple. So this is my solution for that one. Then minus like that, or subtract, then you got the answer. So actually this is the answer for this one. And then the second one, 36, is here, and then the third row is here, and then the last row is here. So that is my answer for number 9, and this is my solution. Okay, so number 10, again, getting the broadcast address. So this is number 10. Again, how to get the broadcast address is just get the network address and subnet address, then compare each octet with each other. If you see 255, then automatically copy the network address. If it is 0, then just write down 255. If not, then apply the rule number 3, which is this one, which is 256 minus the crazy number here, and then the answer will be multiplied by itself, or multiply by 1 2 3 4 5 6 7 and so on, and then find the nearest highest number and then minus to 1. So my answer for number 10 is 205.36.72.63. So yep. So last part is what is a network address? So network address is any logical or physical address that uniquely distinguishes a network node or device over a computer or telecommunications network. It is also a numeric symbolic number or address that is assigned to any device that seeks access to or is part of a network, while broadcast address is an IP address that is used to target all the system on a specific subnet network instead of single host. In other words, a broadcast address allows information to be sent to all machines on a given subnet rather than to a specific machine only. And however, the gateway address, or the default gateway, is a router interface connected to a local network that sends packets out of the local network. And also, the gateway has a physical and a logical address. Yep. So that is all about my presentation for my course project, and thank you for spending your time with me. Goodbye.